Welcome to the lecture series of Numerical Methods. Today we are going to discuss about double integrals. Double integrals under numerical integration. The topic is evaluation of double integrals. This is the last topic under this unit. First rule, under this there are two rules. The first one is trapezoidal rule. Let the given double integral of the form I is equal to double integral a to b and c to d f of xy dx dy, then the rule is I is equal to hk by 4 into sum of the four corner values, that is values available in the circle, plus 2 into sum of the values available in the rectangular box, plus 4 into sum of the remaining values. This is a formula for trapezoidal rule under double integration. See the formula trapezoidal rule for double integration. This formula can be shown in the diagrammatically. That is, when we are doing the problem, we will enter the value as we have noted in the difference table, how we have calculated the difference table values, x values and y values, first difference, second. Likewise, here also when you are giving the values for x, the first value is x0, y0. That value will be denoted here. Likewise, x0, y1, x0, y2, likewise 0 to the last value of y, that is m. Likewise for the x and y, the last values n and m. If you are making the values in the table manner, we can make the last, that is the corner values in the circle, and the middle values in the rectangular box, and the remaining values in the middle. That is the reason why easily to remember the result we have written like this: I is equal to hk by 4 sum of the four corner values, that is values available in the corners, that is the circle values. Easily to remember the formula we have written like this, plus 2 into sum of the values available in the rectangular box, that is in between the circle the values denoted in the box, and plus 4 into sum of the remaining values. In the center values we can take it as 4 into sum of the remaining values. That is the reason why we have written like that. When we are doing the problem, we can easily understand the result. So this is the result under trapezoidal rule. Look at the first problem. Evaluate double integral 0 to 1, 1 to 2, 2xy divided by 1 plus x square into 1 plus y square dx dy using trapezoidal rule with h equal to k equal to 0.5. Evaluate double integral 2xy by 1 plus x square into 1 plus y square dx dy using trapezoidal rule with h equal to k equal to 0.5. In the single integration also we have applied a trapezoidal rule. Here it is a double integration. That is the reason why it is given h and k. We know very well that h is nothing but difference between the x data and y values, that is difference between the y values denoted by k. That is the reason why h and k is given here, because we are using double integration with respect to x as well as y. So in this problem the x limit and y limit is given in the question. What is the x limit? X limit is first integration with respect to x and then y. So the inner integration is 1 to 2 and the outer integration is 0 to 1. So obviously the x value start from 1 to 2 and the y value is 0 to 1. We have to take the difference between the limit is 0.5. So look at the solution, and we know very well that without dx and dy the remaining is the function. Okay, so from the given we can write first f of xy. F of x comma y is nothing but without dx dy, remaining whatever given in the question, that is our f of xy. So 2xy divided by 1 plus x square into 1 plus y square. This is our f of xy. Also given that, okay, this is all given in the question itself. Also given that h is equal to k equal to 0.5. Here the x limit, what is our x limit? X starts from 1 to 2. And what about the y limit? Y limit is 0 to 1. Okay, 0 to 1. For both the values the difference is 0.5 is given. So what is our x data? X data starts with 1. So 1, 1.5 and 2. This is our x values. Corresponding y values are 0. It starts with 0 and 0.5 and 1. Is it clear to you all how to write the x data and y data? So after written this and all, we will make a table. In this one, we will take the x value and y value in the table. Okay, x data values and y data value. What is our x values are? X values are 1, 1.5 and 2. Corresponding y values 0, 0.5 and 1. Our f of xy is 2xy by 1 plus x square into 1 plus y square. So how we are going to fill the table is, for x we have to put the values 1, for y corresponding value is 0. Okay, so we have to substitute here x value is 1 and y value is 0. This first value is 0 only, because 0 into anything, y value is 0, 0 into anything 0, 0 by anything 0. Obviously, the first value is 0. Likewise, we have to fill all the values in the table. After fill the table values, we can go for the result. So, after fill the values, that is x value and y value, we have to substitute in the f of xy all the x and y values. We got this one. Okay, so in this one, we have the result is sum of the 4 circles, that is the 4 corner values. So these are the corner values. Okay, so if you want, we can make it as a circle. So these are the circle. Okay, circle values. Okay, sum of the 4 corner values. Okay, and if you want, we can put the, it's not necessary, just to understand only we are writing like this. If you want only, we can do like this, otherwise you can do without doing all these such things. Okay, so circle values, rectangular box values, remaining values. So we can write the formula. I is equal to hk by 4. H and k both are 0.5. Okay, whole divided by 4 into sum of corner values 1, 2, 3, 4, 0 plus 0.5 plus 0 plus 0.5. Okay, so we have finished the first one, plus 2 into sum of the rectangular box values. So plus 2 into 0.4 plus 0.4615 plus 0.32 plus 0. Okay, plus 4 into remaining values, that is the middle values, 0.3692. Okay, so after substitute all the values in the formula, easily we can remember the formula, because I is equal to hk by 4, sum of the 4 corner values, plus 2 into sum of the values in the rectangular box, plus 4 into remaining values. Okay, so substituting all the values, after using the calculator, we can get the answer as 0.3024875. Okay, so this is the value under trapezoidal rule. So the answer is 0.3024875. So how to do the problem under trapezoidal rule for double integration? First write the f of xy and h and k values. With this only we can write the x data and y data, integration with respect to x as well as y. So the inner integration, that is the inner limit is for x and the outer limit for y. So x varies from 1 to 2 and y varies from 0 to 1. With this we can write our x data and y data. After write down this all the values in the table, we can go for the result. Substituting the values using calculator, we can get the answer as 0.302. Okay, so this is under trapezoidal rule for double integration. So under the double integration, we have the next result is Simpson's 1/3 rule. Okay, so under the double integration, we have two results. First one is trapezoidal rule and the second one is Simpson's 1/3 rule. The rule is, consider I is equal to double integral a to b and c to d f of xy into dx dy. Then the rule is I is equal to hk by 9 f00 plus f20 plus f02 plus f22 plus 4 into f10 plus f01 plus f21 plus f12 plus 16 into f11. So this is the result under Simpson's 1/3 rule for double integration. Okay, so for the double integration the result is differ from Simpson's ordinary 1/3 rule and double integration rule. Okay, so using Simpson's rule, first problem, using Simpson's rule, evaluate double integral 0 to pi by 2 and pi by 2 to pi cos of x plus y into dx dy. Okay, with h equal to k equal to pi by 4. Here it's mentioned that using Simpson's rule, it's understood that Simpson's 1/3 rule. Okay, because Simpson's 1/3 rule is for double integration. It's no need to mention that 1/3, simply Simpson's rule also it's understood that it is Simpson's 1/3 rule only. Okay, it's similar to the trapezoidal rule. First we will write the given f of xy. Okay, so look at the solution. F of xy, given f of x comma y equal to except dx dy, what is given in the question, that is in the integration, that is our f of xy. So here f of xy is cos of x plus y. Okay, cos of x plus y, and it's given that integration with respect to x as well as y. That is the reason why it's given h equal to k equal to pi by 4. That is the reason why it is double integration, isn't it? Pi by 4. And what about our x limit and y limit? Inner integration is with respect to x, outer integration with respect to y. So obviously x value starts from pi by 2 to pi, okay, ending at pi, and the y limit is 0 to pi by 2. Now it's given in the question h and k equal to pi by 4. With this only we can write our x data and y data. So our x data start with pi by 2. Okay, it start with pi by 2, adding pi by 4 because h is equal to pi by 4. So pi by 2 plus pi by 4, we can get 3 pi by 4, again pi by 4, 4 pi by 4, that is pi. So this is our x values, and similarly y values start with 0. Okay, adding pi by 4, so 0 plus pi by 4, pi by 4, ends at pi by 2. So pi by 4 plus pi by 4, obviously pi by 2. So we have completed our x data and y data. So what is the next step? It's similar to the trapezoidal rule for double integration. First write the f of xy, hk, x limit and y limit, x data and y data. The next step is we are going to fill the table. After fill the table values, we can write the formula. Can take the x value and y value. So x values are pi by 2, 3 pi by 4 and pi. Similarly corresponding y values 0, pi by 4 and pi by 2. Okay. So now in the f of xy, what is our f of xy? F of xy equal to cos of x plus y. So we have to give x value is pi by 2. At the same time we have to give our y value is 0. Likewise x value is pi by 2, y is pi by 4, x is pi by 2, y is also pi by 2. Likewise we have to substitute here. Using calculator we can fill the table. Okay. So after fill all the values in the table, we will write the formula. I is equal to hk by 9 f00 f20 02 22 plus 4 into plus 16 into f11. How to find out these values f00 and f20 and all? Okay, here all the problems under the numerical method, when we are getting the x data and y data, we used to mention the x values and y values as x0, x1, x2, isn't it? So here in this problem we have our x0 is pi by 2. Okay, this is our x0 and this is our x1 and x2. Likewise y0, y1 and y2. Okay, so with this only we are going to fill the value. How to fill the values in the formula? Look at this, f of xy, that is cos of x plus y. So this is our x0 and this is our y0, isn't it? So if you want, we can mention like this. This is our f00, okay, and this is our f01, because x value is 0, this is our y value, that is x0 and this is y1, and this is x0 and y2. So this is nothing but what? f02. Okay. Likewise this value is nothing but 1 0 because x1 and y0. So this is nothing but f10 and this is nothing but f11, okay, and this is nothing but f12. Likewise this also, if you want you can simply write like this: x0, x1, x2, okay, y0, y1, y2. To avoid the mistake we can mention like this. This is better I think. And here this is nothing but what? f20, okay. So this is nothing but f20 and this is nothing but f21, and the last value is f22. Is it clear? So if you are writing like this we can avoid the mistake. It's not necessary, just to avoid the error I am writing like this. Okay, now easily you can fill the values. f00, that is the 0 value, and f20, this is -1, and f02 -1, and f22 0. This is also similar to the trapezoidal rule. This is what, as I told you already, that Simpson's 1/3 also similar to the trapezoidal. Look at this corner values, okay, similar to the trapezoidal rule only. And look at this 4 into f10 and 01, okay, 10 and 01, 21 and 12, 12 and 21. Is it clear? Plus 16 into remaining values. So both the formula are similar only. The way of representation is differ. That's all. Easily you can remember this also. Sum of the corner values, rectangle box values, remaining values. Same thing only. Instead of that wordings, here we have mentioned like this. For the trapezoidal rule also, this kind of notation is available in the textbook. You can see that also. Okay. So now we can substitute the values of h, k and remaining values. What is our h and k? H is also pi by 4 and k is also pi by 4 whole divided by 9. Okay. f00 is 0 and f20 is -1. And f02, that is also -1, and f22 is 0, okay, plus 4 into f10 and 01. f10 is minus 0.707 and 01, okay, minus 0.707, okay, plus f21 and f12. f21 is minus 0.707, okay, and f12, that is also minus 0.707, plus 16 into f11. f11 is -1. So after substituting all the values using calculator, we can get the answer as minus 2.00875. So this is the required answer for the given integration. Okay, so this is the problem under Simpson's 1/3 rule for double integration. Okay, so the Simpson's 1/3 rule and trapezoidal rule, both the rule are similar only. So only the representation is different, that is here hk by 9, in trapezoidal rule it is 4, and the way of writing the formula is little bit different, but similar to the trapezoidal rule only. So this is the problem under Simpson's 1/3 rule for double integration. So up to this unit is completed. This unit is over. In the next lecture video onwards, we will go for the next unit in the numerical methods. Okay. So thank you for watching.